Upcycling is actually recycling old material and turn that into something new. Only in the last 100 years, we forgot about this way of efficiently used material. So even in Roman times, they used the food packaging like amphora, the terracotta packaging, to use as building material for aqueducts, to fill the cement. The spolia in the Renaissance, they took the old classical Roman marble columns to build the churches. The Chinese use rice husk as a reinforcement, a glue, natural glue for the cement, to build a ram earth foundation and for Great Wall of China. In modern context, for example, this water bottle that we're very familiar with on a daily basis. In any urban economy, you got water being packaged this way. This is PET, this is PP. Even these two raw material are actually single material. They can be separated mechanically, and these are literally one of the most abundant resources we have on a daily basis, and the resources is actually ever increasing. The supply of these packaging materials, these polymer, actually are perfectly good to be reused in the second life or the third life. E-waste recycling is the next trend of huge amount of trash resources that's coming in. First of all, it has huge amount of precious metal that's in any electronic waste. Traditionally, that's what people collect. Many developing nations are collecting electronic waste and open burn them. This is the most toxic way of extracting precious metal. So we collaborated with SDTI, one of the big e-waste recycler in Asia, and they are actually doing mechanically e-waste recycling. So they're basically chopping them down and separating the metal and the plastic out. Okay, so now all of a sudden you have instead of burning the electronic waste, now you have the metal part, then you also have the plastic part. The plastic are actually quite precious in the electronic waste, alongside, of course, with gold, platinum, silver. Those are, everybody knows that's valuable. But the waste plastic in electronics are very high grade, like polycarbonates, like CDs. Even in the electronic waste recycling, there's a lot of leftover material that you cannot use at the current system. So, for example, like the circuit board, you will have lots of epoxy, lots of short chain glass fiber after the recycling. These materials normally are really bad if it's go into the air or the incinerator. So what we're trying to do is take that. These are naturally fireproof ingredients or aggregates. We're using that for building material. We're actually using that for sun shading facades. So the whole system is naturally fireproof because of, just imagine, sand and glass. It doesn't really burn. So that project is about demonstrating, first of all, the mechanical e-waste recycling at a different scale, massive campus scale. The other is obviously using the least amount of carbon footprint, taking the waste of a e-waste recycling and turn that into something that's useful for building applications. One of the biggest challenge we have is that people overestimate the risk. They worry that whether the consumer is going to take recycled material. The designer overestimated the risk of using recycled material too within this linear supply chain because they're not familiar with it, they're not comfortable, they're used to traditional material that achieve a certain consistency. On the supply end, it's also difficult because people overestimated the risk of integrating recycled material into the manufacturing. There's a fear, okay? There's an overestimated risk and fear that doing sustainable recycled material is going to be more expensive. It's going to be more costly. The cost of recycling, it's the energy required. So the price of recycled material can definitely be cheaper than virgin material, 100%. Without the desire by the leadership of corporate leaders to push down the supply chain, it's almost impossible for any of this closed loops concept to be executed. Because without that forward thinking or a long-term thinking, strategic thinking of the leadership, it's really difficult for that urgency to trickle down all the way down to the material supply, to prove to the leadership that the circular economy works. One, financially it has to be lower than the existing, whatever you're procuring right now. If you just recycle existing resources or trash resources that's out there in the market, post-consumer or post-production, doesn't matter. But in general, you will have tremendous carbon saving. The energy footprint you embedded into the new production, if you use recycled material, is at least 60% to 80% less. If you use less energy, you use less chemical to produce new material, of course you're going to have financial savings. The supply of trash is growing by 70% a year. This is crazy, okay? So just imagine you have a raw material supply source that's potentially going to keep growing, keep growing, keep growing. I don't see how you can increase costs. You're going to have lower costs in the long run. The second is has to have higher performance. You want to make trash material very desirable. It has to have better performance. It has to be sexier. It has to be even more interesting than the existing product offering. Okay, so you kind of create a pull with recycled material. Okay, on the marketing design side. The third is definitely also a strategic level for the management. You got to think about the future of innovation process. It's going to deal with transparencies. It's going to deal with accountability. It's also going to deal with this matrix-based thinking, the cross-disciplinary innovations. By using closed-loop economy and as a way to instigate your own team or creative teams to groom a set of creative professionals internally within the company to deal with this new way of thinking, new innovation within the supply chain, I think you're going to optimize the system further. You can even make your company even more efficient. And that is both in the midterm and long run, it's going to be very beneficial for any corporations.